experiment. The first one is objective of the experiment. Second is introduction. Third is work procedure. Fourth, data collection. Fifth, analysis and discussion. Sixth is conclusion. Seventh is the questions and answers. And last one is reference. Objective of the experiment. The first one is to measure the resistivity of semiconductor materials by using the 4-point probes. The second one is to determine the energy band gap for semiconductors.
The question is temperature important in this experiment? What is meant by resistivity of semiconductors? What are the samples that we use in these experiments and why? For probes method, what is that? What are the apparatus used? And why do we need to measure the resistivity of the semiconductor? Is it important?
Resistivity is the material property that pertains to how difficult it is for electrical current to flow through said materials. Materials with high resistivity are known as insulators, while materials with low resistivity are known as conductors. The resistivity of a material is temperature dependent. The temperature dependence of the resistivity is different from conductors, semiconductors, and also insulators. The energy gap between the conduction band and the valence band decreases with an increase in temperature. The valence electrons in the semiconductor material gain energy to break the covalent bond and jump to the conduction band at higher temperature. This creates more charge carrier in the semiconductors at high temperatures. The higher concentration of charge carrier decreases the resistivity of the semiconductor. As the resistivity of the semiconductor decreases with an increase in temperature, it becomes more conductive. We use 4-point probe method in this experiment. A 4-point probe is a simple apparatus for measuring the resistivity of semiconductor samples. By passing a current through two outer probes and measuring the voltage through the inner probes allows the measurement of the substrate resistivity. In addition, the junction between the N and P-type materials behaves as an insulating layer, and the cell must be kept in the dark. We use germanium in this experiment. It is because it has lower band gap and has higher conductivity. In addition, by lowering germanium's resistivity, it increases the ability of germanium to conduct electricity. Doped germanium is utilized in camera lenses, infrared spectroscope, electric guitar amplifiers, and many more. What is the importance of measuring the resistivity? The resistivity of a material depends upon several factors, including the material doping, processing, and environmental factors such as temperature and humidity. The resistivity of the material can affect the characteristic of a device of which it's made, such as the series of resistance, threshold voltage, capacitance, and other parameters. Work procedure of this experiment. The first one is the sample of germanium was placed on the base plate of the 4-probe arrangement. Then the part holding the 4 probes was unscrewed and let the 4 probes rest in the middle of the sample. The second one is the outer pair of the probes leads to the constant current power supply, and the inner pair to the probe voltage terminal was connected. The third one was 4-probe arrangement was placed in the oven and fixed the thermometer in the oven through the hole provided. The fourth one is the AC mains of the 4-probe setup was switched on, and the digital panel meter was placed in the current measuring mode through the selector switch. Next, the digital panel meter was placed in the voltage measuring mode. In this position, LED facing and it glows, and the meter read the voltage between the probes. The sixth one is the oven power supply was connected and the oven was switched on. Measurement for increasing temperatures was recorded. The next one is the distance between the probe and the thickness of crystal W was measured. The last one is the oven was switched off and the voltage for decreasing temperature was recorded.
As you can see, this is the easiest setup for the M1 experiment using the 4 probes method. Here, we have the 4-probe sample, which is N-type germanium crystal, constant current generator, oven power supply, manometer for measurement of current and voltage, a thermometer for readings in degrees Celsius. In 4-probe arrangement, the 4 probes are arranged linearly in a straight line at an equal distance is 1 mm from each other. A high impedance source is used to supply the current through the outer 2 probes in determine the resistivity. An oven is provided with a heater to study the variation of resistivity on the sample at different temperature. In data collection, we use germanium as a sample in these experiments and a constant current which is 5 mA. These are the data obtained in these experiments. There are two different ways to measure the voltage. First, from the increasing temperature, we take an initial temperature from 40 degrees Celsius until it reaches at 140. While decreasing temperature, the same way will apply, but this time we turn off the heat and took the voltage from the highest temperature to the lowest. There are 22 voltage data measured in total, varies within the temperature that we obtained in these experiments. The resistivity of the sample can be calculated by the temperature of oven and the voltage. In these experiments, we took the readings from degrees Celsius, so we have to convert it to Kelvin by adding 272 Kelvin.
This is part and the distance between probe S is 2. So this is table 1. From the experiment, we have to find the voltage and we also have to calculate the resistivity. And we also have to find the voltage and resistivity from temperature decreasing, which is from 430 until 313 Kelvin. For part 1, the temperature increase. This is the second table, which is table 2. We have to calculate the ln probe, which is ln times resistivity and the voltage and temperature already given in table 1. And we also have to find 1 over temperature. From the previous table, which is table 2, we have to draw this graph to find the gradient and to calculate the energy band gap. This graph, it increases linearly and then bend or curve downwards. From that graph, we find that the gradient is 293.3, and from the gradient value, we can find the energy band gap by using this formula. So the energy band gap for the increasing temperature we get is 0.505 eV. For part 2, temperature decrease, we also have to draw the table, this is table 3, and the voltage temperature already given in table 1, and 1 over temperature is just the same as table 2. For temperature decreasing, we also have to draw this graph. It also the same, it increases linearly, and then when it reaches a certain point, it will bend downwards. From this graph, we also have to find the gradient, and the gradient for the decreasing temperature we get is 5125, and from the value of the gradient, we can get the energy band gap value, which is 0.883 eV for the decreasing temperature. For the percentage error of temperature increase, we get 24.62%, and for temperature decrease is 31.79% since the theoretical value is 0.67. And the discussion part, as you can see in the picture, all of the electrons for germanium crystal were completely filling the valence band. And from the table, when the temperature increased, the voltage also increased because the conduction is great, since the free electrons and the holes are created faster, because when the voltage increases, the electrons will move faster. So the third one is the voltage is measured using 4-probe method, because we can easily get an accurate resistance value between the probes. And as the temperature increases, the energy band gap of semiconductor decreases because the interatomic spacing increases when the amplitude of atomic vibrations increases due to the increasing in the thermal energy, and this effect quantified by linear expansion coefficient of a material. The number 6 I already explained on the graph. The graph increase linearly and bend curve downward because the germanium crystal is extrinsic at the curve region because the temperature is low, and when it increases linearly, the germanium crystal is intrinsic. So there are some precaution steps that needed to be taken in order to obtain accurate results, such as we have to check the conductivity of each wire before doing the experiment, and next we should get the average value of the experiment so that the reading would be more precise. Okay, for the question, what is the advantage of 4-probe method over the other conventional method? So this method can be used to measure resistivity more accurately. Okay, so the next one, can we use an ordinary millivoltmeter instead of electronic millivoltmeter? So we cannot use the ordinary millivoltmeter because the current applied to the experiment were very small, that is exceeding milliampere and millivoltmeter. So the third one, explain the behavior of the long versus curve. Let's calculate the EG from the curve. So the graph increase linearly and then bend curve downwards. Meanwhile, the energy band gap value already calculated, and we get that when the temperature increase is 0.505 eV, and when the temperature decreases 0.883 eV. So the last question, why a semiconductor behave as an insulated at 0 Kelvin? So semiconductor behave as an insulated at 0 Kelvin because there is no electron was able to cross the energy gap due to the absence of kinetic energy.
In conclusion, the resistivity decreases as the temperature of semiconductor increases. It can be proved from the equation given. It means the conductivity of the semiconductor is increased, so the current flow is also increased. The energy band gap for decreasing temperature is 0.833 electron volt, while the energy band gap for increasing temperature is 0.505 electron volt. The energy band gap was calculated by using the equation.